Please like my video and share my videos with your friends and colleagues, and subscribe my channel if you have not already subscribed. Thank you. We will now discuss the solution of a problem that appeared in the CSIR National Eligibility Test held in the month of July 2024. The question is from the section Analysis, and the problem is related to the properties of continuous functions. This question is from the part C, which is a multiple select question. There can be more than one answer, and it carries 4.75 marks. The question ID is 704067. This question is suitable for the aspirants of JL, DL, TS set, AP set, IIT JAM and GATE. The given question is, let f be a function from the set of real numbers into itself, and it is given to be continuous and one-to-one. Then which of the following statements are necessarily true? We are given four options. Option 1, f is strictly increasing. Option 2, f is strictly decreasing. Option 3, f is either strictly increasing or strictly decreasing. Option 4, f is onto. Let's now discuss the solution of the problem in detail. We are given a function f from the set of real numbers into itself, and it is given to be f is continuous and one-to-one function. The following result is well known. Theorem: if I is an interval of the set of real numbers, I is a subset of R, which is an interval, and f is a function from I to R, which is continuous one-to-one function, then f is either strictly increasing function or strictly decreasing function. That means this statement, f is either strictly increasing or strictly decreasing function, is necessarily true. Therefore, the option 3 is true. We discuss the remaining options in the next slide. Assume that the options 1 and 2 are true. That is, 1. If f r to r is a continuous one-to-one function, then f is necessarily strictly increasing function. Option 2. If f is a function from r to r which is continuous one-to-one function, then f is strictly decreasing. Now, is it so? No. If you want to say no, we give two counter examples. Now let g of x is equal to minus x and h of x is equal to x. These are very familiar and well-known functions. It is very easy to see that g and h are continuous and one-to-one. Yes, they are very easy. Here, g is a strictly decreasing function, h is strictly increasing function. Now g is continuous and 1 to 1, but g is not strictly increasing, it is decreasing. So therefore it is not necessary, if g is continuous and 1 to 1, that it should be strictly increasing. G is not strictly increasing, it is strictly decreasing. So g is continuous and 1 to 1, but g is not strictly increasing. H is continuous and 1 to 1, but h is not strictly decreasing, it is an increasing function. So therefore these outcomes are not necessarily true. So therefore the options 1 and 2 are not necessarily true. So we are left with option 4. Let's see that in the next slide, for which we again look for a counter example. For that, we take f of x is equal to e power x. It's well known. F of x is equal to e power x is a continuous function, yes, on R, and f of x1 is equal to f of x2 implies e power x1 is equal to e power x2. Taking the logarithms on both sides, we get x1 is equal to x2. It tells you f is a 1-to-1 function. Right. So that is now f of x is a continuous 1-to-1 function, but it is not onto. Why? Because its range is the open interval 0 to infinity, which is not equal to R. It is a proper subset of R, which is not equal to R. So range is not the whole of the codomain, therefore it is not onto. Thus f R to R is a continuous 1-to-1 function, then f is not necessarily onto. F is not onto always, it is same as necessarily not. Right. So the option 4 is not true. Right. The answer to this question is option 3. And that is the detailed discussion of the solution of a problem which is based on the properties of continuous functions from the section analysis. I am sure that you have understood the solution of this problem. You have been watching my videos. If it is so, please like my videos and share the videos with your friends and colleagues. Please subscribe my channel if you have not already subscribed. I wish you all the best. Thank you.